Hi, I'm Carl Nelson, and we'll be talking about a portable Venomanometer system for episcleral venous pressure measurement. The problem that we're addressing is to detect traumatic brain injury, particularly in the mild to moderate range. The difficulty of this arises because the typical methods that are used, for example in sports medicine or in the military, involve a relatively subjective cognitive performance test against the baseline. So it would be really nice to have a quantitative biomarker that tells us whether TBI has been induced. Fortunately, we do have a quantitative biomarker. Elevated intracranial pressure, ICP, has been linked to the onset of traumatic brain injury. However, ICP is really hard to measure. It's very invasive. And so we're interested in an alternative newly emerging biomarker called episcleral venous pressure, which allows us to take a surface measurement of a vein on the eye and detect how much pressure it takes to half blanch that vein. We use a special device called an Episcleral Venomanometer, which is typically used in glaucoma research. And based on the coupling between pressures in the veins system of the eye and the cerebrospinal fluid in the brain, we have this relationship that allows us to use EVP as a quantitative biomarker for TBI. The problem is that since EVP is typically used in glaucoma research in a clinical setting, the equipment that's used to measure EVP is not really suitable for field settings such as locker rooms or battlefields. So instead of a slit lamp or an operating microscope, we want to get some kind of low-cost device that is more field deployable. So here's what we developed. It is basically an accessory kit for the existing Venomanometer, where we package it with a fine adjustment mechanism, which allows us to precisely position the Venomanometer against the episcleral vein in the eye, and a smartphone, which allows us to do image capture, image processing, data logging, and data transfer. We accessorize that with some added lenses and lighting, which help us to create the good optical conditions for getting high-quality images. And we add a potentiometer onto the Venomanometer because the reading on the dial is a reading of pressure, and we want to read that electronically and merge that with the image. So we actually put a potentiometer on there, use a processor to feed that reading back to the smartphone, aggregate the data, and overlay the pressure reading on the image itself. So within the app that's customized on the smartphone, we can take still or video images, manage the files, and adjust focus and zoom, and see the pressure reading overlaid on the image. So it's really kind of user-friendly. We've tested this in rabbits, and we've been able to show that there is a favorable performance of our integrated system to using the basic Venomanometer in more of a clinical standard use scenario. You can see that we get really good image quality with rabbit eyes, and we can detect the half-blanch condition that allows us to measure EVP. Cost-wise, we keep it relatively affordable. The Venomanometer itself is under $1,000. We add a smartphone to it for a few $100s, and our added components, which are mostly off-the-shelf parts, are less than $500 added cost. And keeping it this inexpensive is really great because we've got a really big market that we can address. Globally, the concussion diagnosis market is estimated to be about $1 billion, and this breaks down for us into two really large, obvious market segments. One is sports medicine, and another is defense. And so these are our two biggest targets. Fortunately, the original Venomanometer design is not a limiting factor in our ability to produce a commercial product out of this because the original Venomanometer patent is no longer active, and our main developments that are being added to this are mainly in the software that's being run on the smartphone to kind of pull all the pieces of data together and facilitate decision-making about the presence or absence of TBI. Hope you enjoyed this presentation, and I'll be happy to take questions in the Q&A session.